Now in this video, we'll be making some changes on how we plot the transfer function. So before we jump into the discussion, let's first have a review on the topic on decibel scale. So decibel scale is usually used in communication systems. So we define a gain, which is actually the log of the ratio of the power output over the power input, and we call the unit in terms of bells. Now, another measure is the decibel, which is a smaller gain, and it is defined as 10 times the log of the output over the input. To get some meaning regarding uh, what they mean by decibels, for example, we have a ratio equals to 1. So we'll get a decibel value of 0. So meaning we actually don't have any gain. So we don't have, this is classified as no gain. Now, if you have a ratio of 2, that means the power output is doubles the power input. You will have a decibel value of 3, which simply means that the gain has doubled. If you have a ratio that is less than 1, let's say zero point 0.5, you will get a gain that is negative 3, which simply means that the gain is only half, or the output is only half of the input, which is actually a loss. Now, it's also possible to get a decibel for the ratio of voltages or current. But since power is proportional to the square of the voltage and the current, we define the decibel for these ratios as 20 log of the ratio of the voltage or the current. Okay, so how do we go about the changes in our plots? So first, let's define what we mean by semi-logarithmic scale. Now, in this scale, the horizontal scale is not shown as a normal scale. So as you can see here, the major divisions are shown as powers of 10. So we have 0.11, 10, 100, 1000, and so on. And also the divisions between the major divisions are not equally divided. So for example, 2 here is farther to 1 than 3 is farther from 2. Okay, so we call this scale a logarithmic scale. Now it is so called a logarithmic scale because if you're going to get the log of the major divisions, so log of zero point 0.1 is negative 1, log of 1 is 0, log of 10 is 1, and so on. You actually get the normal scale. Now, on the other hand, the vertical scale is still the normal scale. It is not a logarithmic scale. So therefore, we call this graph a semi-log graph because only one scale is shown as a logarithmic scale, which in this case is the horizontal scale. So how do we go about the changes in our on how we plot the transfer function? Now we call this plot the Bode plot, and this is how it goes. So we we plot the magnitude of the transfer function in a semi-log graph. So both the magnitude and the phase actually. And in addition to that, the magnitude is also taken not as its normal value, but in terms of decibels. So meaning that we show the magnitude as decibels. So we get the log of h and multiply it by 20. and then plot this on a semi-log scale. So this is how the magnitude of the transfer function looks like. So the horizontal scale is a logarithmic scale, and the vertical is in terms of decibels, as defined earlier. Now, on the other hand, the phase angle is also plotted as a similar graph. The only difference is that the vertical scale is still plotted as in degrees. So let's apply this new way of plotting the transfer function. So in our previous example, we have the transfer function expresses this, the magnitude, and we have this phase angle. Now let's plot this using Bode plots. So we simply get the log of h and multiply it by 20. So we have this, applying the normal properties of logarithms. And doing so, we'll get a plot which is like this. So how does this plot goes? So for smaller values of omega, we'll notice that the value of the transfer function, the magnitude of which approaches zero, and as we increase omega, the magnitude in dB actually decreases. It becomes a negative dB. Okay. On the other hand, for the phase angle, for smaller values of omega, uh, the angle starts very small. Actually, it would also approximately be zero for probably omega equals zero. Well, at zero point 0.1 omega radians per second, you have a negative 9.11. And as omega increases, it also decreases. Actually, it goes to negative 180 degrees as omega increases to a bigger value. Okay.